Today we are going to discuss some of the problems on differential equation representation for continuous time LTI system. First problem, find the natural response for the system described by the differential equation phi into dy of t divided by dt plus 10 into y of t is equal to 2 into x of t, given y of 0 is equal to 3. Solution for this: the given system d into phi into d into y of t divided by dt plus 10 into y of t is equal to 2 into x of t, and y of 0 is given 3. So to find natural response, we have to consider input x of t is equal to 0. That is to get the homogeneous equation. Therefore, phi into dy of t divided by dt plus 10 into y of t is equal to 0. We are going to call it as equation number 1. Now, to get the characteristic equation, replace dk y of t divided by dt to the power k is equal to r to the power k. Then, from equation number 1, we get characteristic equation as 5r plus 10 is equal to 0 or r is equal to minus 2. Therefore, the natural response equation is yn of t is equal to summation I is equal to 1 to n ci into e power ri of t. Then the natural response becomes yn of t is equal to c into e power minus 2t. Call it as equation number 2. Substituting y of 0 is equal to 3 in equation number 2, we get y of 0 is equal to 3, which is equal to c into e power 0 or c is equal to 3. Therefore, natural response yn of t is equal to 3 into e power minus 2t for t is greater than or equal to 0. Next problem, find the zero input response of the system described by the differential equation d square y of t divided by dt square plus 3 into dy of t divided by dt plus 2 into y of t is equal to x of t plus d into x of t divided by dt. Given y of 0 is equal to 0 and dy of t divided by dt at t is equal to 0, which is equal to 1. Then we have to find out the natural response of the equation with x of t is equal to 0. That is d square y of t divided by dt square plus 3 into d y of t divided by dt plus 2 into y of t is equal to 0. Then the characteristic equation is r square plus 3r plus 2, which is equal to 0. Then the roots are r1 is equal to -1, r2 is equal to -2. Since both the roots are real, then the natural response yn of t is equal to c1 into e power r1 of t plus c2 into e power r2 of t, or yn of t is equal to c1 into e power minus t plus c2 into e power minus 2t. Call it as equation number 1. Then dyn of t divided by dt is equal to minus c1 into e power minus t minus 2c2 into e power minus 2t. Call it as equation number 2. By putting y of 0 is equal to 0 in equation number 1, we get c1 plus c2 is equal to 0. Call it as equation number 3. Then by putting dy of t divided by dt at t is equal to 0 equal to 1 in equation number 2, we get minus c1 minus 2c2, which is equal to 1. Call it as equation number 4. By equation number 3 and 4, we get c1 is equal to 1, c2 is equal to minus 1. Therefore, the natural response yn of t is equal to e power minus t minus e power minus 2t, where t is greater than or equal to 0. Next, determine the natural response for the system described by the following difference equation: d square y of t divided by dt square plus 4 into y of t is equal to 3 into dx of t divided by dt, with y of 0 is equal to -1 and dy of t divided by dt is equal to 1 at t is equal to 0. Then the homogeneous equation d square y of t divided by dt square plus 4 into y of t is equal to 0 by assuming x of t is equal to 0. Then the characteristic equation, we get r square plus 4 is equal to 0, or r is equal to plus or minus 2j. Therefore, r1 is equal to 2j and r2 is equal to minus 2j. Since the roots are purely imaginary, then the natural response yn of t is equal to c1 cos 2t plus c2 sin 2t. Therefore, dyn of t divided by dt is equal to minus 2c1 sin 2t plus 2c2 cos 2t. Call it as equation number 2 and call the previous equation as equation number 1. Then it is given y of 0 is equal to minus 1. Substituting in equation number 1, we get c1 is equal to minus 1. And by putting dy of t divided by dt at t is equal to 0 is 1 in equation number 2. We get 2c2 is equal to 1 or c2 is equal to half. Therefore, c1 is minus 1 and c2 is half. Then the natural response yn of t is equal to minus cos 2t plus half sin 2t at t is greater than or equal to 0. Determine the forced response, which is also known as zero state response, represented by ZSR. For the system given by 5 into dy of t divided by dt plus 10 into y of t is equal to 2 into x of t, with input x of t is equal to 2 into u of t. It is given 5 into dy of t divided by dt plus 10 into y of t is equal to 2 into x of t. We will call it as equation number 1. Then the forced response occurs due to the input only and it has natural response and it has particular solution. Then y f of t is equal to yn of t plus y p of t. Then the characteristic equation to find natural response, phi r plus 10 is equal to 0 or r is equal to minus 2. Therefore, natural response yn of t is equal to c into e power minus 2t. Call it as equation number 2. Then the particular equation or particular solution, it is given x of t is equal to 2 into u of t. It is a constant. Then the particular solution yp of t is equal to k. Call it as equation number 3. Then substituting equation number 3 in equation number 1, we get 5 into d of k divided by dt plus 10k is equal to 2 into x of t, which is equal to 2 into e of t, which is equal to 2 into 2, which is equal to 4. Or 0 plus 10k is equal to 4, or k is equal to 2 divided by 5. Therefore, forced response yf of t is equal to c into e power minus 2t, which is natural response, plus 2 by 5. Then, to finding the forced response, we have to assume initial condition y of 0 is equal to 0. We call it as equation number 4. Then, from equation number 4, we get c into e power 0 plus 2 by 5 is equal to 0, or c is equal to minus 2 by 5. Then yf of t is equal to minus 2 by 5 into e power minus 2t plus 2 by 5, or 2 by 5 if I take outside 1 minus e power minus 2t, where t is greater than or equal to 0. Find the forced response of the system d square y of t divided by dt square plus 9 into y of t is equal to x of t, where x of t is equal to cos of 4t. It is given d square y of t divided by dt square plus 9 into y of t is equal to x of t. Call it as equation number 1. Then we know that forced response yf of t is equal to yn of t, natural response, plus particular solution. Then the characteristic equation to find the natural response is r square plus 9 is equal to 0, or r is equal to plus or minus j3. Therefore, yn of t is equal to c1 into cos 3t plus c2 into sin 3t. Since x of t is equal to cos 4t, then yp of t is equal to k1 into cos 4t plus k2 into sin 4t. Call it as equation number 2. Then substituting equation number 2 in equation number 1, we get d square divided by dt square into k1 cos 4t plus k2 sin 4t plus 9 into k1 cos 4t plus k2 sin 4t, which is equal to cos 4t. After simplifying, we get minus 16 k1 cos 4t minus 16 k2 sin 4t plus 9 k1 cos 4t plus 9 k2 sin 4t which is equal to cos 4t, which is equal to minus 7k1 cos 4t minus 7k2 sin 4t, which is equal to cos 4t. Then comparing LHS and RHS, we get minus 7k1 is equal to 1 or k1 is equal to minus 1 by 7 and minus 7k2 is equal to 0 or k2 is equal to 0. Therefore, yf of t is equal to c1 cos 3t plus c2 sin 3t minus 1 by 7 cos 4t. Call it as equation number 3. Then dy f of t divided by dt is equal to minus 3c1 sin 3t plus 3c2 cos 3t plus 4 by 7 sin 4t. Call it as equation number 4. Assuming 0 initial conditions, that is y of 0 is equal to 0 and dy of t divided by dt at t is equal to 0 is 0, we get c1 minus 1 by 7 is equal to 0 or c1 is equal to 1 by 7 and 3c2 is equal to 0 or c2 is equal to 0. Then yf of t is equal to 1 by 7 cos 3t minus 1 by 7 cos 4t, which is equal to 1 by 7 if I take outside cos 3t minus cos 4t. T is greater than or equal to 0.